In every optometrist's office, a chart like this one is used to check your vision by reading it from 20 feet away. If you're able to read the row of letters on line 8, then your vision is a very healthy 20/20. If not, you will probably be advised to get a prescription for a pair of glasses. Our eye is an amazing instrument made of various transparent substances, all trapped in a 1-inch ball. Light first enters the eye through the cornea, where it bends the most, traveling through the lens, which bends it some more. An image of the observed leaf is formed at the back of the retina, called the fovea. The optic nerves pick up the light signals and send them to the brain. The image of the object is flipped upside down, but the brain flips it back so it seems upright to us. The eye is also controlled by various muscles. The iris is a muscular structure that changes the size of the pupil, and therefore controls the amount of light that goes into the eyeball. On a bright day, the iris contracts to prevent too much light into the pupil. When it gets darker, the iris expands to let more light in the pupil. The large muscles outside the eyeball allow it to move right, left, up, down. The small muscles near the lens can change its curvature and adjust its focus until a clear image is formed at the retina. To understand how the focus of the lens depends on its curvature, let us look at 3 lenses A, B, C. Lens A is the most curved and has the closest focus. Lens C is the least curved and focuses further. Lenses that focus light are called convex or convergent. Another common lens has a shape that spreads light, and it is called concave or divergent. Watch what happens when you place a convex lens ahead of another convex lens, compared to placing a concave lens ahead of a convex lens. In a normal eye, the cornea and lens focus the image on the retina, forming a clear image. This is not always the case though, and many people need their vision corrected because they suffer from hyperopia or myopia. If an eye suffers from hyperopia, the focus is beyond the retina, and the image is therefore blurry. A convex lens is used to gather the light rays so that the eye can focus sooner to form a clear image on the retina. If an eye suffers from myopia, its focus is before the retina, and the image is again blurry. A concave lens is used to spread the light rays and shift the focus further to form a clear image on the retina. An optometrist uses a machine called a refractor, which conveniently switches the lenses with different focus abilities. The patients look through the eyepieces at a chart with letters, while the doctor asks how clearly they are seeing. At the end, the optometrist will prescribe a set of glasses. The doctor will also check for other conditions that influence vision, but that will be the subject for another time. Thank you for watching. Chapter 8 of Lightlab also has hands-on science activities and a Bible lesson about the transformation of Paul from a persecutor of Christians to a fearless apostle of Christ. You can also read the book of Acts, chapters 8 and 9, to learn how Paul was blinded by God to show him he was already living in spiritual darkness. When Paul miraculously regained his vision, his focus switched to Christ, whom he obeyed and served the rest of his life. In a letter to the Philippians, Apostle Paul said, "I press on toward the goal to win the prize for which God has called me heavenward in Christ Jesus."